So in the previous module, we've learned that if we have some atom, for example, let me take the example of oxygen. So oxygen has an atomic number of 8, which means it has 8 protons, and therefore it also has 8 electrons in its neutral state. So if I draw oxygen, here I have the nucleus with 8 protons and 8 neutrons, and here I have the first shell with 2 electrons, and here I have the second shell with the remaining electrons. So 2 are there, so the remaining 6 electrons, 1 2 3 4 5 6 electrons fit in the second orbit, and 1 2 3 4 5 6 7 8, I have the 8 electrons filled, right? Now the outermost electron can fit up to 8 electrons in the second shell. The second shell can fit up to 8 electrons, but here I have only 6 electrons. Now in the last video I had explained you that completely filled shells are more stable, and obviously, and also according to the octet rule, we had learned that any atom to be in its most stable form would want to actually achieve 8 electrons in its outermost shell. So in the case of oxygen, you have 6 electrons in its outermost shell, so oxygen would really want to sort of have 2 more electrons so that it can have 8 electrons. Now the number of electrons an atom wants to have, now I'm emphasizing on the word want to, because you have to keep in mind that atoms don't really want something. It is just that if they gain those 2 if oxygen gains those 2 electrons, it will be more stable, and therefore, and yeah, it is a general trend in the universe that objects want stability. Everything moves towards a more stable configuration. That is just based on probability. Let's not get into that, but the basic idea here is that the number of electrons, so I'll just write here, the number of electrons any atom, and now I'll put this in quotes, wants to achieve or get, let's keep the word simpler, is just its valency. So valency is the number of electrons any atom would want to get in order to achieve the stable configuration of 8 electrons in its outermost shell. Now in the case of oxygen has a valency of 2, and because it lacks 2 electrons, so if I just write the symbol of it, oxygen, because it lacks 2 electrons, so its valency is actually -2. What does the minus signify or suggest? It simply represents that oxygen wants 2 electrons. It really wants 2 electrons, so it will take 2 electrons from somebody or someone. We are not going to do that right now, but the basic idea is that oxygen wants 2 electrons and it lacks 2 electrons, and that negative sign tells us that oxygen lacks the 2 electrons. So that is the valency of oxygen, -2. Now if we move on to another example here, let me take quickly another example here. Instead of taking oxygen, let us take sodium, for example. So sodium, on the other hand, if I look up in the table, has an atomic number 11. So that means it has 11 protons in its nucleus, and around the same number of, so in sodium has actually 12 neutrons, but that doesn't matter here. So it has 11 protons, 12 neutrons in the nucleus, and to be neutral it also has 11 electrons. Now those 11 electrons are spread over, are distributed in all its various shells. So this is the first shell of sodium, which has 2 electrons. Then we have the second shell, so where are remaining, so 11 minus 2 is 9, so where are remaining 9 electrons will be filled, but we can only fill up 8 electrons. 1 2 3 4 5 6 7 8. So that's it, because this second shell has a capacity of 8 electrons only, so we will have to fit our last electron in the third shell. So here I have the third orbit or third shell, and I put my third last electron here. So sodium has 1 2 3 4 5 6 7 8 9 10 11 electrons, and it only has one electron in its outermost shell. So that is how the electrons are distributed over its various shells, and it has only one electron. Now what do you think, how many electrons does this atom of sodium want to, in order for its outermost shell to have 8 electrons? Now you would simply say that the answer is very simple. It is 7, because it already has 1. It needs 7 more electrons for it to have 8. 7 plus 1 is 8, so it to have 8 electrons in its third shell, which is its outermost shell. But then sodium would look at you and say, like, come on, I don't want to gain 7 electrons, because now that it has a reason. Why would it not really want to gain 7 electrons? Because right now it is neutral. It has 11 protons, 11 electrons, perfectly neutral. But if it gains 7 electrons, it will also gain the charge of those 7 electrons, and it will have a net negative charge of 7 electrons. Now that net charge will make it kind of unstable, because then it will be attracted to all sorts of positive atoms around it, and that is something that the sodium doesn't really want. Now again, I'm using the word want, but yeah, the point is it will make the atom less stable. So sodium would simply say, why to get into such a trouble of gaining 7 electrons and gaining that large amount of charge, when I can simply get rid of this 1 electron here? And yeah, that is also a good idea. So what I can do is, this sodium atom can simply get rid of this 1 electron from here. Now the electron will obviously not just vanish. Let's say the electron just comes out and is kept here separately, and now sodium has 1 2 3 4 5 6 7 8 electrons in its outermost shell, which is its second shell now. And yeah, it has achieved the golden number of 8 electrons in its outermost shell, and sodium is very happy. And now obviously it has gained a net positive charge, because now it has 11 protons but only 10 electrons. So it has an extra protons charge, which means it has a net positive charge. But yeah, that positive charge of 1 proton is much better than having a negative charge of 7 electrons. And yeah, we'll have to think about what to do with this electron, but we'll come to that in the next video. For now, let's keep it there. And the sodium atom is very happy here, because it has achieved 8 electrons in its outermost shell. And if I have to just write the valency of sodium is Na. The symbol of sodium is Na, and the valency of sodium is simply equal to +1. Now what does this plus suggest? It simply suggests that sodium likes to give this 1 electron away to achieve those 8 electrons in its outermost shell, or achieve that stable state. And that plus state just tells us that it has to give that electron in order to achieve that stable configuration. Here the minus suggests that oxygen has to take those 2 electrons in order to achieve the stable configuration, whereas sodium has to give that 1 electron in order to achieve that stable state. So yeah, the signs don't really mean anything. This just suggests that the atom has to either give or to take the electrons, and the number simply tells the number of electrons that it has to take to achieve this stable state, stable configuration. So that's all there is to valency. That's it for this video.